I'm Rob Jodrie, Technical Support Manager with SyncWorks, and I'm going to talk about third generation bits clocks. So to talk about the third generation bits clocks, it's helpful, I think, to kind of discuss where this all kind of came from and where this all started. So the first generation of bits clocks that was brought into the network back in the day. First of all, bits clock, building integrated timing supply is what the acronym is. Lots of names for these things, right? Clocks, bits, TSG, timing signal generators, all kind of the same thing. It's the idea, the concept was that all the networks in the central office would be referenced by the same Stratum 1 traceable reference. The Stratum 1 traceable is a highly accurate, very stable reference that if you tie all your digital network elements to that reference, everyone is transmitting and receiving at the same nominal rate. And that's how you achieve network synchronization. That's kind of the goal of this whole thing. So, and in an ideal world, all NEs, all network elements in an office, and in fact, across the country, across the globe, are traceable to Stratum 1. So it's important that if you've got offices in Manhattan and they're connected via fiber to central offices in New Jersey, everybody's got to be Stratum 1 traceable, because if they aren't, if the New Jersey sites are not Stratum 1 traceable, now your digital bit streams are not operating at the same nominal rate. So that's again kind of the key here. So the first gen bits clocks were primarily hardware-based. Optioning was done via dip switches. So you'd break out a little, your pencil or your pen, and you would, throw dip switches to option B8ZS and framing formats and all that kind of thing. The alarming was pretty basic. You had these discrete alarms, these contact closure alarms. You would get a minor, a major, or a critical. That's what you got. There was a major alarm. Didn't know what it was. You'd dispatch somebody there, and they'd check it out and see what was going on. So this notion of a bits clock, why do we deploy them? The communications network was evolving from frequency division multiplexing to time division multiplexing. And the systems that you still see in many cases today, when they were evolving, back in the 70s, 80s, and 90s, digital cross-connect systems, the old 3-1 DACs, they called them. You would multiplex T1s into T3s, digital carrier systems, digital switching machines, the Western Electric's 5ESS, Northern Telecom's DMS switches. These all needed timing because they were digital interfaces to these systems. The transport systems, SONET was everywhere. SONET and SDH in Europe, SONET here in North America. And SONET, the acronym Synchronous Optical Network. Synchronous is the first word in the acronym. So that's what drove this need to get all the equipment tied to a common reference. And these first gen bits provided frequency-based timing. So it was a DS1, a framed DS1 signal, or a composite clock, a 64 kilobit digital signal.